is Peter Madsen. I am 27 years old. I live in Helsingør with my girlfriend and my 2 kids. I have 2 daughters. And I study here at DTU as a PhD in the Metro Access short-range communication groups at the Photonics department. My work here consists of actually producing signals and modulation formats for these signals, which actually reduces the bandwidth of the signals, so that we can actually reuse some of the electronic components that are out there in the existing networks that are implemented around the world, and still use signals with a fairly high speed. I have been studying here at DTU almost all my life. I started with 1 year in a bachelor study in computer science, but I found out quickly that that wasn't really the route for me. Then I thought, what the hell, let's try DTU. And I actually came to like it very, very much. So I did my bachelor's here in what was at that time called IT and Communication Networks. And then I finished that and started directly on my master's, which is a master's also in communication technology. And now I'm here as a PhD within the same field of communication technology. My PhD program is sponsored by the Wilhelmsfonden, and it's very nice that they have given me this opportunity to actually produce all this interesting work within the fields of communication technology. And yeah, as part of this, I'm part of a project called the SEAS project, which is a project designed to actually reduce the energy cost of the networks by looking into, for my case, the modulation formats. So the term SEAS stands for spectrum efficiency and energy efficient signaling. So that's actually what the program is all about. We're actually trying to produce some modulation formats that can, in a very efficient manner, reduce the energy cost of the networks that we're using. And this is done, for instance, by lowering the bandwidth, in my case the bandwidth of the signal, so that the electronic components, you don't need to upgrade them for stuff that actually uses more energy, or you can actually go the other way around, reduce whatever signal you're using in your system right now, and then cut away some of the electronics that you're actually implementing in your system. That could be, for instance, if you have a WDM system where you actually need the extra bandwidth, and then you can cut away some of the extra lanes that you have, and that reduces your energy cost. As part of this SEAS project, I'm actually looking very much into the modulation format called polybinary signaling, where we actually we produce a multi-level signal from an NRZ standard seed, and this actually produces up till recently we have 1/5 of or 1/3 of the bandwidth that the NRZ normally required. This means that the electronic bandwidth is actually reduced to 1/3 of what it actually was before, and this is an amazing thing to implement into the network, because you can actually lower the energy consumption of your electrical components, because you don't need the bandwidth that you did before. So by reducing the bandwidth, we can actually go into a data center, for instance, and say, now you're using a lot of lanes inside your server, optical lanes, and you might need this because of your bandwidth is increasing. But if we can actually lower your bandwidth by introducing a new modulation format such as polybinary signaling, you can actually cut away on these lanes, or maybe turn off a whole server in times where you actually don't have your peak hours, because you have the bandwidth already ready on the other servers that you're already running in your data center. This means that you can actually choose either to lose the power from the entire server, or some of just the lanes that you're actually having, which means a huge energy deduction in your server cost, which is amazing. Working in a university is really great, because on one side you have all the things you need in order to do your research. We can go to the lab, we can ask our colleagues, because people know just as much as you. I imagine this wouldn't be the same in a private company, where you might be the specialist guy hired for a single job, and your questions might not be covered by your colleagues. But here it's a completely different manner, because people here actually know what you're doing. They might not be as much into your subject, but they can help because they are working on related subjects. The good thing about this also is the flexibility. I have 2 kids at home, so if I need to run an experiment, I can do that in off hours. And then some other days, for instance, if one of my kids is a little bit lazy and sleeps a long time, then I can just meet here later and then go home later. It's one of these small flexibilities that just make my personal life and the life of my kids and my girlfriend really easy, and yeah, it's so good. The other thing about working in a university is that you have all the other students around you all the time. So it's this very great society or community of people that are learning and studying. So everywhere you go, you see people studying, you see people, some maybe partying, and you like, oh yeah, I remember that time when we were out drinking all night, and you just have these fun moments and remember all this stuff with your colleagues. And yeah, so and most of the colleagues here are also former students, so it's really nice. It's great. The atmosphere is really nice. From my PhD, in a short perspective, I hope that I will be really successful and publish a lot of papers, and people will remember my name within my field and stuff. It would be very nice. And of course, graduate with very nice results. That could also be really good. Or even if I could find something, maybe discover something fundamental, and it will be like, oh, we've never seen this before. That could be really awesome. But I don't hope to expect that. In the long term, it could be really great to come out here with out of the PhD being the specialist within polar binary signaling and modulation formats. So be this kind of the go-to guy in a company when people are having some troubles with modulation formats, or they need some kind of bandwidth reduction or something like this. They can go to me and I can say, yeah, let's use this and this modulation formats on top of what already system you have, and we will be in the home run field. Yeah, that would be really nice. Deciding to become a PhD was really, I think, the most optimal thing for me, both from a life decision standpoint, but also from the natural perspective of being a student and being here at DTU and then just continuing that track for a little bit longer. Seemed like the really good thing to do, and I'm really glad that I decided or was given this opportunity and decided to say yes to the opportunity of actually becoming a PhD. So if anybody wanted to become a PhD student here at DTU, or if people think, oh, should I seek a position here as a PhD, I would say yes, go for it, because it's really great. It's a lifetime opportunity. It will change your perspective on a lot of things when you come to Denmark and you start studying within a technical field, and you have all these great guys around you, colleagues and stuff that really are into just the same matter as you. There is just knowledge everywhere. It's so nice.